Hello everyone, and welcome to the Geometric Series video notes. So let's go ahead and begin. So the first part of understanding what a geometric series is understanding what a geometric sequence is. So a geometric sequence, this is the formula for it, looks something like this. So if we start with 1, then go to 3, 9, 27, ... So here we can see that we're multiplying by 3 every time. So here, this formula is just a way of calculating what number goes to which term. So let me just define this formula for you. A is the term, so this is A1, A2, A3, A4. N is the number of the term, so first, second, third, fourth. The ratio is what you're multiplying by every time to get that term, so the ratio for this is 3, because you're multiplying by 3 to get every next term. So that is what a geometric sequence is. And now let's get into what a geometric series is. So here is the formula for a geometric series, which looks a little bit more daunting. But basically what a geometric series is it's very similar to the last one, where you have 1, 3, 9, 27, and so on. But now we're adding up all of the terms. So let me define the terms of a geometric series for you. So R is still the ratio, which is still 3. N is the term number, so 1, 2, 3, 4. And A1, that's the first term, and that's about it. So that is the formula for a geometric series. So now let's go ahead and start practicing with the first problem in our notes. So here it gives us n equals 12, and then it gives us the start of a geometric series. So from here, we need to start defining some terms. So for the formula, we need A1, and the first term here is 5. And then we need the common ratio, and how we get that is we just divide two terms that are next to each other. So we have 15 divided by 5 equals 3. So R equals 3. So from here we can start hashing out our formula. So we have S of n equals A1 1 minus R to the n over 1 minus R. So let's start defining these terms. A1 is 5 times 1 minus 3 to the nth power, which is 12, all over 1 minus 3. So let's go ahead and plug this into the calculator and get our answer. So if we plug this formula into a calculator, we get 1,328,600, and that is our answer. So let's move on to number 2. So number 2 is a little bit different because we have our n and we have our A1, but we do not have our R. Instead, we have an A5. And this is where the geometric sequence formula comes in handy. So we have 1 over 80 1, we know that's the 5th term. So if we set that equal to A1, which is 1, times our rate, which we do not know, so we will put R. And then n minus 1, we know that n is 5, so here it is 4. So anything times 1 will be itself, so we can get rid of the 1 here. And then what we'll do is just 4th root it. So the 4th root of 1 over 81 is 1 over 3, and that is equal to R. So now that we know that R equals 1/3, we can use the formula. So let's do that. S of 6, dropped my marker. S of 6 equals our A1, which is 1, times 1 minus our rate, which is 1 over 3, to the power of 6 over 1 minus 1 over 3. So if you plug this into the calculator, you get S of 6 equals 1.498. So this is when stuff starts to get a little bit different, because now we're using a new notation, sigma notation. So sigma notation is a lot easier than it looks. It's the exact same as the last formula, just moved around a little bit. And I already have the pieces color coded here. So let's do this. So we have S of n. Here you can see that n equals 6 because it's asking for all terms from 1 to 6. So S of 6 equals our A1, which is 3 times 1 minus our rate to the n minus 1, which is 5. All of this over 1 minus R. So if we plug this into our calculator, we have alpha y equals, that's how you get a fraction, 3 times 1 minus 4 to the 5th over 1 minus 4. Press enter, we get 1023. So here, S of 6 equals, what did I say? 1023. Nice and easy. So if we look back at the sigma, we can see that this is n from 1 to 6. This is our A1. This is our rate, and then just n minus 1. This is what we call the rule. All right, for number 4, it's a bit different. We have to work backwards. So S of n here equals 820, and we do the equation like normal. a1 equals 1, so there's no real point in writing it. 1 minus r to the nth power, and we do not know n, that is what we are trying to find, over 1 minus r. So the way that we do this is we simplify this to -8 first, and then we multiply both sides by -8 to get rid of this -8. So we have 820 times -8, which if I plug that into my calculator is -6,560 equals 1 minus 9 to the n. We can subtract the 1, so we have -6,561 equals -9 to the n, and then factor out a -1 from both of them. So we have 6,561 equals 9 to the n. So you may be wondering how we calculate this, and that is by using a logarithm. So if I get a different sheet of paper here, we have 6,561 equals 9 to the n. So if you all remember, we can do log base 9 to the 6,561 equals n. And then just plug that into our calculator. And we know once we plug this log into our calculator, we get n equals 4. From here, you should be able to do every problem in the homework and the rest of the notes. So, thank you for watching.